welcome to part 2 of set theory. In this video, we're just going to look at surds as well as a bit of complex numbers. So let's try to look at surds. Let's try to look at surds. Okay, so here, without wasting time, let's just dive deep into concepts that we're supposed to pay attention to since the preparation. We're going to look at different rules that we're supposed to follow. Number one, we need to understand that the root of a multiplied by the root of a, this is under multiplication, we're going to have what is known as a. The question is how. To those of you who are failing to understand that root of a multiplied by root of a, the answer is a. Here is a breakdown. So when you've got the root of a times a, the answer is a squared. Since you're getting a squared, you realize that the root and the power, the 2 and the root are going to cancel, and you're going to get a. In simpler terms, we used to say the square root is the same as 1 over 2. That's how we used to do things. So the root, in this case, when I've got root a, it's more like root a squared. It's more like someone is telling you that you've got a squared in brackets, then you've got 1 over 2. So these two are reciprocals of each other, implying that you're going to get, when you multiply them, you're going to get a 1, which will eventually give you a to the power 1, which is the same as a. That's what it means. Then the other one, under multiplication, this thing where you're multiplying two different things under the root. You've got root of a multiplied by root of b, and you're going to get the square root of a b. I love this rule because it's really important in simplifying surds. Let's try to see an example on that, on the two rules that I've just outlined here. So an example that I can give, on the first rule is basically the root of 2 multiplied by the root of 2, which is eventually going to give us a 2. How? Because the root of 2 times 2, that's a root of 4, which is going to give us a 2. But in the case where we have got the root of 3 multiplied by the root of 2, and we're going to end up with the root of 6. This is more like having the root of a multiplied by the root of b to give us the root of ab. In this case, the ab is the 6. But I said this rule is very nice because it tells us a lot. Let me try to take you back, guys, to primary school, where we used to look at numbers like 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Did you know that 0 is an even number, and numbers start with even, odd, and they keep on going like that. The first number is an even, followed by an odd, even, odd. That's an even, odd, even, odd, even, odd, even. You realize that even the definition, which says an even number is a number divisible by 2 and the number itself, we realize to say it's making sense. It's making sense. So now, apart from that, I would also want you guys to at least just know the perfect square numbers. The perfect square numbers that are coming from these 10 numbers. So what is 0 squared? Is basically 0. 1 squared is basically 1. 2 squared, that's 4. 3 squared, that's a 9. 4 squared, that's a 16. 5 squared, that's a 25. 6 squared, that is a 36. So these numbers that I've written here are basically perfect square numbers. I can keep on going up all the way up to 100. But here's the thing. You can be given a question to say, maybe simplify the square root of maybe 2 root 27 plus maybe 3 root 12. So here is now the importance of knowing those numbers. You're going to assess the kind of number or the type of number that is in under the root. So in this case, looking at 7, here is 7. 7 is an odd number, implying that 27, the entire 27, is an odd number. What does that mean to us? We're supposed to break down 27, since we can't find the exact root of 27 without using a calculator. I mean, you're going to have, this is 2, open brackets. Let's break down 27 into the form of root A multiplied by root B, of which one of them, between A and B, is supposed to be a perfect square number. I repeat, break down root of 27 into root of A multiplied by root of B, of which between A and B, one of them is supposed to be a perfect square number. Now, how are you going to find that perfect square number so fast? It's by assessing the type of number that is under the root. In this case, the number that's under the root is an odd number. So we'll focus on the perfect square numbers. If you're looking for a perfect square number, we'll focus on the numbers that are odd. So we'll go here. 1 is an odd number. We know that 1 can go into 27 times, but doesn't make sense. Let's go to the next odd number. In this case, it's 9. So 9 can go into 27. How many times? 3. Meaning you have found our perfect square number. In this case, it's 9 multiplied by how many times it can go into 27, which is 3. This is how easy you can break down a number into each root and how many times. This is how you can break down 27 into a perfect square number and a number that shows how many times that particular perfect square number goes into 27. Then plus, that is 3, I would say, open brackets again. What is it going to give us? Even in 12. 12 is an even number. So I need to look at a perfect square number that I can pick, and when I multiply it with a certain number, it gives me 12. So in this case, since it's an even number, I'll just target even numbers. In this case, I'll go for 4. Since 4 is the lowest, is an even number, is a perfect square number, which is an even number, but it's lower than 12, which can go into 12 as well. So 4 into 12 is basically 3. So I can have, this is root 4 multiplied by root 3. Like that, it means that we're moving. So implying that we're going to break down what's in the brackets. That's in the brackets. What's in the brackets? So root of 9, that's 3, multiplied by root of 3, which is root 3. Plus, that is 3, open brackets. Pay attention to how I'm writing, because it can save you mistakes. That is, save you on mistakes. So that's root of 4, that is 2, multiplied by root of 3, like that. So implying that we can say this is 2 times 3, giving us a 6, root 3, plus 3 times 2, that is also a 6, root 3. When you put these together, they're going to give you 12. Why am I adding this? If you have got similar numbers under the root, the only thing you get to do is add the numbers outside the roots. If you're using addition, if you're using subtraction, subtract the numbers outside the root. In this case, we are adding, because this is 6 plus 6, which is giving us a 12, and just bring down root 3. Because if the numbers under the root are similar, just think of them like x or y. So in this case, you can think of it as 6x plus 6x, which is going to give you 12x. Like such a thought is very useful. Yes. Yeah, like that. So that's how you can simplify Surds in a simplest way. For example, what if you're given, say, the root of 75? Simplify. How can it go? How it can go is basically go back to the perfect square numbers. What perfect square numbers are odd numbers? But so I've got perfect square numbers such as 9. From 9, another perfect square number, which is an odd number, is basically a 25. From there, another perfect square number that is an odd number, that is a 49. But don't look at it. When I say 49 into 75, it can't go. But 25 into 75 is going there how many times? 3. So implying that I can break this down into root of 25 multiplied by the root of 3. The only secret is you knowing that I need to break down 75 into two things. I'm going to break it down to root A multiplied by root B. That's what it means. Where A is a perfect square number and B signifies how many times this perfect square number goes into 75. And I helped you to say, look at the type of number that is under the root. In this case, it's 75 and it's an odd number. So meaning even the perfect square number that you're looking for must be an odd number. So in this case, you're going to get that is 5 root 3. So this is how you can simplify. You can simplify Surds. So when you're looking at division of Surds is going to be in part 3 of another YouTube channel. Just try to look for part 3. That is going to be that's going to be on division. We are going to look at, for example, if you have been given root 3 minus root 2 over maybe root 2 plus 3. When you look at these two, you realize to say, they ask you a question to say, rationalize the denominator. Rationalize the denominator. So what you do is you look at the denominator and find the conjugate of the denominator. So finding the conjugate of the denominator, since it's just root 2 plus 3, what we're just going to do is we drop root 2 like that, then just change the sign in between root 2 and root 3. In this case, it's positive, meaning you're going to have minus 3. So this is the conjugate of root 2 plus 3. We just change the sign in between. Then we are going to multiply both the numerator and the denominator by root 2 minus 3 over root 2 minus 3. Thereafter, we're going to simplify. So this is what is going to be in part 3 of the YouTube video, and you're going to solve all the way to complex numbers.